Howdy, everyone. We did a autonomous golf ball collector for our final project. I'm Jacob Goss. I'm the integration engineer.
I'm TJ, and I'm TJ Coetzee. I'm the software engineer.
My name is Gary Mullins, and I was the hardware engineer.
So our project, what we wanted to do is create a mobile robot that uses LiDAR and a tracking camera to detect golf balls and collect them using a homemade apparatus that rotates with as the robot moves and collects the golf balls.
So for the system overview, we had 3 inputs. It would be the camera, the LiDAR, and the encoders. The camera would be used for color tracking to identify golf balls. The LiDAR would be used when detecting obstacles. And the encoders would just, I guess, manipulate the data so we can process it and give commands to the robot using the left motor, the right motor, and the actuator.
So this project did need some hardware, of course, because it had to pick up the golf balls. So of course, we had our sensor hardware, so that would be our camera and our LiDAR, and of course the Scuttle robot platform itself. And then the hardware that we had to create was a collector that was suited to the size of the Scuttle. We also needed the, of course, golf balls and the motors.
For this project, the 3 things that we needed to focus on was processing the inputs, calculating the desired motion values depending on whether the robot detected an object or an obstacle, and then to command the motors to collect the balls or avoid obstacles.
Here's an overview of the timeline that we've followed throughout this project. So we're, of course, at the conclusion. We've already done our demo, and we're just finishing up our presentation. And here we'll go into the implementation of the robot and basically what we actually did to complete the requirements. So like we said before, one of the components of this project was the custom hardware. And although it looks a little crude, with engineering, with the freshman classes in mind, of course, we wanted to keep things simple. So this was made out of cheap supplies, and it actually does the job pretty well. The steel brackets give it a sort of adjustability that lets you set the amount of sort of normal force you want between the roller and the ground. Because if this force isn't enough, it's going to push the golf ball away. But if it's too much, it actually sort of induces a load onto the Scuttle that really messes with its ability to operate accurately. So we sort of messed with a couple combinations of both the cross members. We started with steel wire, but it was a little bit too stiff and hard to work with. So we eventually found the right sort of ratio of rubber bands that would allow the container to roll over the golf ball and contain it without posing too much resistance to the motion of the vehicle.
One of the aspects of the coding was the navigation of the robot. When it's searching for a target, it would search in a 360-degree pattern until one is identified. If a golf ball is not identified, then it would drive forward 1 meter after a full rotation to search from a new position. But if it did detect the golf ball, it would use the alignment and tracking function that is used in the L3 color tracking to drive forward and position itself until it was aligned. Once the robot was aligned with the target, it would drive forward 1.5 meters and to collect the ball, and then it would repeat its search pattern. As for obstacle avoidance, this would start being used once a ball or target has been found and is trying to approach the target. It would look for any obstacle that is 0.5 meter away from the LiDAR, and if it would search from -75 to 75 degrees. So it would look at 150-degree view within a half meter. If the object was to the left of it, it would rotate. It would rotate clockwise 30 degrees, drive half a meter forward, and then rotate 40 degrees counterclockwise to face towards the target that it was originally looking at. And if it was within 0 to 75 degree, 0 to -75, what I said previously was 0 to 75. If it was 0 to -75, then it would rotate counterclockwise first, drive forward, then rotate clockwise to look at the target again. And this would repeat until the object is no longer obstacle is no longer detected from the LiDAR.
So this is our distribution of efforts. I'm the integration engineer, so I kind of helped with both sides, more on the software side of things. We all had a part in the project report, the presentation, and the proposal itself. I helped TJ develop the software, as well as test the software and troubleshoot any problems we had, as well as helped Gary a little bit with assembling the ball collector on the scuttle. TJ was responsible for the software development as well as the testing and troubleshooting. And Gary was responsible for the ball collector and mounting it on the scuttle itself. That's our presentation. Thank you for watching.